All right, I think we're going to go ahead and start here a little early, a couple minutes. Give me just a second here, get some controls out of the way. All right, well, welcome to the last Phoenix SWUG for the year. Um, yeah, we're excited. I feel like November's just blown by. I don't know if anyone else. It was end of October a couple days ago, I swear. Now we're halfway through November, but we move on. I am, if I can get this to work. There we go. I'm Dylan Pratt with InterLink Engineering. Uh, we do mechanical engineering design using SolidWorks. This is our 20th year. That's our 20-year logo. So we've been around a while and do a lot of different projects. I'm sure you've all met me before. I do. At least a small presentation ahead of another presenter on some tips and tricks or various little topics here and there. Today, I'm going to talk about multi-bodies and kind of modeling for in a multi-body fashion, however you want to say. There's a couple different terms people use for modeling this way. But essentially it's like modeling assemblies in a part. So modeling it that way versus minimally using assemblies, more using multi-bodies. Um, just out of curiosity, how many people here typically model that way? Or oh, okay, yeah, a couple. All right, not a lot of people. Yeah, that's why I thought it might be a interesting topic to kind of talk through the benefits and why you might do that versus another way. There's definitely limitations. There are times it doesn't make sense. There are times I think it makes a lot of sense, and hopefully you'll come away with a better understanding of when that might be. Um, I list a couple of things here actually. So it doesn't matter the type of manufacturer. So if you're designing for injection molding or sheet metal or weldments, all different types of manufacturing are fine for multi-body. It's not like exclusively injection molded part design. I know a lot of companies that do injection mold design happen to be companies that do multi-body modeling, but it's not exclusively good for that. It's good for a lot of different types. And what you really want to consider is like, do you have a strong connection uh, between given parts, meaning like shared datums or really critical features that are going to be kind of always moving back and forth between the two, linked features, rather something you might typically create an assembly link for, rather than doing that, modeling it from the get-go as a multi-body, I think is often a superior way of doing that. Um, and you're really tying all your critical features together. So if you need to make a change to the one part, it just inherently changes the other part the way you need from the get-go. Um, and then there are some different ways of handling properties and other things when considering like moving over to drawings. So kind of touch on that and, the different things you need to keep in mind if you are going to do a multi-body instead of an assembly, where some things might be a little more obvious with an assembly. So I'm going to go ahead and just dive into a demo here. And I do want to just double check this is still sharing. Okay, yeah, okay. I'm doing this through a remote desktop rather than running this directly off my computer at the moment. Just ended up being an easier way. So if we have any glitches, hopefully we don't. So the first multi-body I'll kind of show you something we put together. This is for a project we're working on. It's like a big sheet metal enclosure, multiple different sheet metal parts or pieces, um, all put together into a larger assembly. Uh, you can see we didn't do all of them in one multi-body. That would have been probably not advisable for a couple different reasons. But one is not all the parts were welded together. Everything in this is welded together. But this then has various other parts bolted on. So some of those parts were modeled in here, but this really made sense as being a critical main weldment and done as a multi-body because so many of these features are tied together and are relating to one another. So if we need to change the whole pattern or size of this cutout, the panel would just need to correspondingly change. So rather than changing having to change multiple parts, it's really just coming in here and changing one part and getting that all to update. Now, and I guess just to show you what that looks like, so you can see here, these are all sheet metal parts or sheet metal bodies within the larger part. And if I needed to, for example, get a flat pattern, I would actually, I mean, there's a couple of different ways to get a flat pattern, but I would actually go down here and initiate the flat pattern, and it'll actually hide and suppress the rest of the components and just show the one component that I'm telling to give a flat pattern to. So that's kind of how the sheet metal works when dealing with that. I lost my train of thought there. I was trying to, I wanted to show one other thing. Well, let's dive into the properties here. So one thing, part of the reason I wanted to show you this is it does get a little different. So whereas in an assembly, you might show something very similar to this on a drawing, a lot of the part numbers and descriptions are all pulled from the part properties, but we don't have separate parts. It's all one part property. So what this actually is still can be a cut list or a BOM. In this case, we did this one as a cut list, but you can do it as a BOM, but you have to change the settings a little bit. And those properties are not writing to a part, but they're actually writing to the file here. So you actually need to go to the bodies and go to properties. And then essentially this is the cut list properties that'll from. So you actually add in the different, oh, sorry, this is the page I was looking for. Threw me off a little. The property summary here. So the different parts you're looking at is like where, now I'm confused. Why is this not the view I'm expecting? All right, one second. There, that looks right. I don't know why that didn't. Oh, was it just scrolled? Oh, that's why it loaded weird. It was like scrolled all the way over. Okay. I was like, this doesn't look right at all. Okay. So when you scroll all the way over to one side, you'll see these properties are just writing to a part number and description that we manually added in. It has all the other cut list properties that may be nice to use, material properties and everything. You could modify all that. You can tell individual bodies, different materials. In this case, it wouldn't make sense because it's all being welded together. It's probably the same material. But all that can be handled there. It's just you need to handle it there rather than, a little different, like I said, that you would do in an assembly. Let's see, there's some other things that are a little, part of the reason I chose this in particular, this is a little bit of a unique scenario where we decided to batch it together this way, but there was some slight oddities that we didn't want to break out because of the way we decided to structure the assembly. So that means we also inputted hardware into this weldment because essentially it's acting as part of the weldment. So what we did was import part. So for example, you go to insert part and actually ignore, we're not going to do this part, but you would grab your McMaster part and essentially drop it in there and then use move body, much like you would use mating to mate your hardware where you want it. This is like permanent installed, essentially welded hardware. So that's why it doesn't exist in a higher level. We decided to cover everything that needed to be installed and welded in this multi-body part rather than doing an additional level. There were reasons why, but You could also totally do it that way and just have this exist and then do an additional level that's an assembly with the hardware. It just depends on how you want to structure things. This is another example. We had a weld-on hinge that was put in here, and you kind of do it all the same way. It just, when you import a part, actually, I'll kind of, oh, interesting. Feature broke apparently. I think the way I loaded this, because this wasn't the, this didn't have all the files downloaded. I was just kind of opening this for reference. It doesn't know where that file is because I didn't download everything correctly. So it's not going to show you, but essentially, long story short, when you import that body, you can tell it to do a move, copy body, essentially again, like a mate would in an assembly. You just tell it where you want that part to exist in this multi-body. Yeah, so that kind of covers, I think, sheet metal. Yeah. Actually give you the mate abilities. Yeah, you know what? Here, this is a little bit of a nonsense part in relation to this assembly, but let me show you just real quick what that would look like. So I have this box here checked, locate part with move body copy feature. So essentially, box that, yes, I want to insert this into that. It will load and then give me the ability to then move body it. Or you can click this constraints button, and then that's where I can say, oh, I want this to be concentric to, let's say, this hole here. And I add that mate, and I want it to be, you know, flush to that face, add mate. So you can do all that. You do only have the simple mates. So this is really for a simple, you know, putting solids together. This isn't, you're not going to do like a slot mate or a mechanical mate, kind of a more complicated scenario, but you can position it where you need to. You do also have the benefit, in some ways you could look at it as benefit over an assembly, is nothing is floating. Once I accept that's where I want the part stays there. There is no moving it accidentally. Like, you know, sometimes an assembly, you know, didn't have a fully defined mated or something, and it, you know, gets moved off the page and you didn't realize. That doesn't happen here, which is kind of cool. So yeah, that's an example of how you might use that in sheet metal, and kind of where you need to look out for on properties and everything. And then really just wanted to also show you, that's why I had this part up. Kind of another example. So this is a injection molded part that really there's two parts here. Injection molded one in a laser cut panel, or injection molded depending on you know, various factors, but essentially two different materials, two different manufacturing processes, but they snap together. And I'll kind of make this part transparent real quick so you can see it a little bit better. But we have a locking feature here. And so really just modeling everything together made a lot of sense for us in this case, made life a little bit easier, because everything is also a configuration. It kind of rebuilds everything together. So I'll just actually change the configuration real quick. So everything's rebuilding in this because we have it all as one multi-body part, and those parts aren't, you know, linked completely. All those features rebuild. You can do things like that in assembly, don't get me wrong, but in my opinion, this is a good use case for where it makes sense. It just builds a lot easier. You're not having to worry about it being in an assembly. Ultimately, we put this in an assembly with the hardware that we use once, you know, these parts go together, but then it's just some off-the-shelf hardware that gets assembled to put the rest of it together. But this is just kind of a good example of how that works and why it's kind of a useful feature. Things like draft, you can make sure everything lines up well together. Yeah, anyway, so that's how that goes together. Let me go back to my presentation here. So that was really just kind of my quick overview on that. I certainly dive deeper in the future if anyone needs, or if anyone has any questions right now, I'd be happy to answer.
Why did you decide to make this multi-body part? rest and assembly?
As far as that sheet metal or the,
Oh,
oh, that, so that, because those two are the only custom parts, the assembled unit is really just, that bolted onto, it's just some hardware basically, and it didn't really make sense. The hardware isn't permanently attached. It's just, you know, some bolts that float in space. So it didn't really make sense to make it a multi-body in that case, from my perspective.
You are able to export that as two parts as an assembly if you want, right?
Yeah, totally. Actually, let me show you that real quick. I actually had intended to show you that and I forgot. So I appreciate you bringing that up. So what you can do, there's a couple different ways to break it out actually. So you can either do a insert into new part. So essentially you can manually its own part and break it out as its own thing. And you know, essentially what you end up with is some would call a master model. So I'm just gonna hit cancel on that, but you end up with a master model. So what you might do is like use these parts in your assembly, but ultimately, if you ever go back to make changes, you would just, you know, you'd open this part and you go, oh, there's no feature tree. Oh, okay, yeah, I'll just go edit the master part, and you say edit in context. It goes back to, for some reason, it's not linking back to, but it should. I think it's just because I didn't have it saved, but it goes back to the master model, and then you make your changes, and they correspondingly link. They update live to one another. So that's one way you can do it. The other way is, I remember how to do this. Save selection. Is that what it is? Oh, okay, that's what it was. Yes, thank you. I don't do this way, so I wasn't as familiar with it, but it's kind of the same thing, but you're doing it all at the same time. Well, you can do it all at the same time to all the bodies, and you're kind of breaking it out. It does have some benefits to do it one way versus the other, but essentially, you know, you do the same thing. You say save bodies, and then actually you click both, and then essentially breaks it out as its own part.
And I think you can, if I saw it right, you can create assembly as well.
Yeah, that's correct. Yeah, and you can and to approach that question differently, because I may not have entirely answered what you were originally thinking. You can also just import this multi-body into an assembly and use it that way as well. And if you wanted to just use the multi-body in the assembly and even make configurations where you're only showing, you know, only showing this one and only showing that one, so you're actually using the real master part in the assembly and just showing the different parts in different places. You can just do that using configurations or display states so that you're not actually breaking them out into their own parts. Or yes, you can break them out into your own parts, their own parts rather, and then do it that way. And then essentially you just treat it the same as you would anything else. And then really you're just getting the benefits from a modeling perspective of having everything linked, but you're not doing drawings or anything in a different way. You're still treating everything as parts. Yeah.